Hello, welcome back students. I am Dolon Banerjee and we are conducting the AKTU's video lectures. So let us continue with the subject which we were carrying on, that is geotechnical engineering. Today we will be first discussing about the plastic limit and shrinkage limit. Okay, plastic limit and shrinkage limit. Okay, we will see into the procedure of the practicals which we will carry out in the laboratory to find plastic limit and shrinkage limit. Okay, so just the practical methods. Okay, let us see one by one. What is plastic limit? First of all, generally, actually, if you see it in a general form or a broad form, then you can see that plastic limit is the part or is the limit of the water content in which the soil remains plastic. Okay, the soil remains plastic. Here is something like, generally this is WL and this is WP. I have shown you the diagram. This much area or this much length of the water content will be called as plastic. Okay, in this part the soil remains plastic. What is plastic? Plastic means the soil can be easily molded into different forms. Okay, so generally this behavior is encountered by fine grained soil only, because in coarse grain the plasticity is negligible. So we are mainly concerned with fine grained only if we talk about plasticity. So but in lab, in order to find how much plastic or what is the range of the plastic or the plastic limit, particularly we can say, we will be defining plastic limit as the moisture content at which the thread of a 3.2 mm diameter begins to crumble. What does this mean? What we do is, suppose this is a flat plate. Okay, this is a flat plate. We will roll a thread or a line or a simple linear of soil. Okay, this is soil for which we are required to find out the plastic limit. So this soil is somewhat like this. This is the surface and this is the soil. Then we will just roll it with our hands. Okay, we will roll it with our hands like this, so that this gets a diameter of 3.2 mm. Okay, 3.2 mm. And when it is at 3.2 mm, we see that what is the condition of the soil, whether it is crumbled or not. What is crumbling means? Slight surface cracks are seen on the soil itself. Okay, and if there is no crumble, then we will again further reduce this water content. We will reduce the water content further and again continue the same procedure. Okay, so generally let us see what apparatus do we require for this. A polyethylene dish, okay, where we will be mixing the soil, glass plate on which we will be rolling the soil, airtight container so that water content can be determined, balance of capacity 200 grams and sensitive, that is okay, and maintain oven mainly just to find out the water content. Okay, so these many things are required for the experiment. So let us see the procedure. First of all, we take 20 grams of thoroughly mixed proportion of material passing through 425 micron sieve. Okay, 425 micron sieve. This ensures that your soil is fine grained. Okay, fine grained, and much of its proportion will be, and much of its proportion will be clay. Okay, much of the portion will be clay, which means it can show good plasticity behavior. Okay, then let us move forward. Mix it thoroughly with distilled water in the evaporating dish till the soil mass becomes plastic enough to be easily molded with fingers. Means we will have to mix the soil with water and then keep on checking that how much plasticity it has gained, means how much molding it can be done with the soil with the fingers. Okay, it should not crumble. Allow it to season for a sufficient time to allow water to penetrate throughout the soil. Means what does this mean? This means that we will be leaving that moist soil for some time to allow it to soak up. Okay, it will soak the water. Then we will take 10 grams out of that, because we have mixed 20 grams. Some part of it is taken out, okay, of the plastic soil mass, and roll it between the fingers and the glass plate with just sufficient pressure to roll the mass into a thread or diameter, uniform diameter throughout, okay, throughout its length. Means just I told you, now again this is the glass plate and this is your soil. We have to roll it in such a way that a thread of 3.2 mm dia is made. Okay. So, what is the rate of this rolling? Rate of rolling will be 60 to 90 strokes per minute. Okay, means 1, 2, 3, 4, like this, 60 to 90. Okay. Continue till you get a thread of 3 mm diameter. Now, once you get a 3 mm diameter soil, the diameter of the soil gets to be 3 mm, then what we do? We again, if it is crumble, if we see the crumble on the surface of it, then that is okay, we have to stop there only, that is our end point. But if we do not see the crumbles on this, suppose this means what? It has a plasticity, it has a water content more than what it has to be, okay, for plastic limit. So, what we do? We will again continue, we will again mix it up, again make a ball, something like this, okay, make a ball of the soil and again start the same procedure. See, here it is shown, he is carrying out the plastic test or procedure. Again we will continue the same, we will continuously do the same. So, knead the soil together to a uniform mass and re-roll. Okay. Continue the process until the thread crumbles when the diameter is 3 mm. Means you have to continue this procedure, means you will be threading it and again you will mix it up, again threading it till we get this part. Okay. See, here it is crumbled, you can see, okay, here it is crumbled or it is broken. So, this is our end point, this is the end point. Okay. This is our end point. So, now what we do? We take a part of this soil, okay, this end point's soil, we will take it and find out its moisture content, means W. This moisture content is our actually plastic limit or WP. Okay. Collect the pieces of the crumble thread in airtight container for moisture content determination. Repeat at the test to at least 3 times and take the average of the results. Okay. Finally, this will be our plastic limit. Okay. This was the practical procedure to find out how plastic a soil is, or how we find the plastic limit of any soil. Now, let us see this is the data sheet for plastic limit. Okay. We will be following the same as we have just now seen in the procedure step by step. What we will do? This is the moisture, we will have to actually what is the plastic limit? It is actually only the water content. Okay. So, just the procedure will be similar to what we do it in the water content determination. Mass of empty container, container plus wet soil, container plus dry soil. If you remember, we did the same procedure for determining general water content as well. So, what will be the mass of water? That will be this minus this. Okay. And mass of dry, this minus this. Okay. So, what is water content? If you remember the formula, water content is WW upon WS. Okay. So, here we have WW, this is the WW and this is the WS. So, this upon this will give you the water content, this you have done here. Okay. So, this will give you the plastic limit. Now, let us go to shrinkage limit test. What is shrinkage limit test? Yesterday I told you that what happens is, suppose the graph, if you remember, something like this, the graph was something like this, and here it was the shrinkage limit. Okay. Here it was plastic limit and here somewhere it was liquid limit. So, this shrinkage limit now we are going to find out in the lab. Remember that when a shrinkage limit or this limit is reached, the volume reduction gets ceased. Okay. Means no more volume reduction, it is constant, you can see. Okay. Let us see now. As the soil loses moisture either in natural environment or by artificial means in laboratory, it changes from liquid state to plastic, plastic to semi-solid, then from semi-solid to solid. If you remember, this is liquid, this is plastic, this is semi-solid and this is solid. So, once we start reducing the water content, it slowly will attain this, then this, then this, then this, means all these states, the Atterberg states which we yesterday completed, or in last lecture we completed. Volume changes also occur with the change in water content. You can see volume is changing. This is the volume, okay. This is the volume and this is the water content. So you can see with the change in water content, volume is also reducing, or if you go in this way, then it is increasing. But there is particular limit at which any moisture content change does not cause soil any volume change, means we are talking about this part, okay. No volume change. Soils which undergo large volume changes with change in water content may be troublesome. Volume changes may not and usually will not be equal, okay. Means for the same soil in different water conditions or different moisture content conditions, the volume change will be different, they will not be analogous, okay. So you cannot derive a particular relationship between them, that at this it will be this only, it will fluctuate according to different conditions as temperature and all. A shrinkage limit test should be performed on a soil. Why should we perform the shrinkage limit test? To obtain a quantitative indication of how much change in moisture can occur before any appreciable volume changes, okay. Means you can just an example, you can see that from here, suppose we move to here, from here to here, so we can see how much volume changes, okay. From this much, for this much water content change, what will be the change in the volume, okay. An indication of change in volume, the same thing, okay. So mainly shrinkage limit is important because a number of soils which have a high shrinkage limit or a high volume change due to change in the water content is not suitable for construction of buildings. They are actually very liable to swell, they are very liable to swelling. This means that they will be causing different harms to the building, that may be cracks. Generally cracks are encountered in such cases. So if there is soiling soil, soiling means to expand, okay, expansive soil. If there are expansive soil, their volume change will be very high with respect to the slight change in the water content. So we have to encounter those, okay. So we will be finding all these parameters first, okay. Let us move on. Now apparatus, shrinkage limit test, we will be seeing the apparatus. Shrinkage dish, okay. Then evaporating dish will be required, a small mercury dish, 2 glass plates, one is plain and another with bronze. What is this? I will show you later on. Glass cup, IS sieve, oven, weighing balance, spatula, straight edge and mercury, okay. Now let us see the procedure one by one. We will continue to understand how the procedure is going on, okay. Take a sample of mass about 100 grams from the thoroughly mixed soil passing through this. Why? Again the same, fine grained, okay. Take about 30 gram of the soil sample in a large evaporating dish, mix it with distilled water to make creamy paste which can be readily worked without entrapping the air bubbles. Means we will make the paste so lean up to that level that we can easily tap it, and or we can take out all the air bubbles which is contained in that, okay. Because air bubbles, if they remain inside, they will cause the error in our readings, okay. Take the shrinkage dish, clean it, determine its mass, okay. This is for empty shrinkage dish, we will determine its mass. Fill the mercury in shrinkage dish, remove excess mercury by pressing the plain glass plate over the top of the shrinkage dish. The plate should be flush with the top of the dish, there should be no air. What does this mean? First of all, you have a shrinkage dish, suppose, okay, you have a shrinkage dish. Now what we do, first of all we take the empty, we take the mass of the empty one, then what we do, then we put a glass plate onto it, so that excess mercury will flow out, okay. Excess mercury will flow out of it, means just the container or the shrinkage dish will be having the flush of mercury, okay. Then we can remove this glass plate and it will be filled with mercury, okay. Now let us move forward. Now what we have to do, transfer the mercury of the shrinkage dish to a mercury weighing dish and determine the mass of the mercury to accuracy of this. what we do, once the dish is flushed, means it is fully filled with mercury, we will transfer it to a dish so that we can measure what is the weight of the mercury. Once we know the weight of the mercury, you know that the density of mercury is 13.6. Density of mercury is 13.6. So, now what will happen? You have mass, you have your density. So, obviously you can find out the volume. Okay. So, we are doing the same here. The volume of the shrinkage dish is equal to the mass of mercury in grams divided by the specific gravity, that is this. Okay. What does this mean? Simply what we will get, volume will be, what happens, see, rho is m by v. Okay. You know this. To find out volume, this will be m by rho. So, we will be using this relation to get the volume. Okay. Now, we have the volume of shrinkage dish. We already have obtained the volume of shrinkage dish. Coat the inside of the shrinkage dish with a thin layer of silicon grease or Vaseline. Place the soil specimen in the center of this shrinkage dish equal to about 1/3 the volume of the shrinkage dish. Tap the shrinkage dish on a firm cushioned surface and allow the paste to flow to the edges. What does this mean? This means now once you have found out the volume, coat the surface of the dish with Vaseline. Why do we do this? So that the soil does not get stuck with the walls of the shrinkage dish. Otherwise, later on when we have to find out the mass, that will give you the error. So, what we do? We coat it with Vaseline or grease. Okay. Then in 3 parts, in first part, then second and third, 3 parts we fill in the lean soil which we had prepared before. That will, what will that do? And then once we have filled it in the dish, we will just tap it on the surface, so that the whole of the soil gets flown to each and every edge of the dish, okay, and make a level surface. Then we will do this continuing 2 to 3 times to fully fill it. Okay. Add more soil and continue the tapping till the shrinkage dish is completely filled and excess soil paste projects out about its head. Now, what we will do? We will strike it off. Okay. We will remove that part, extra part. Strike out the top surface of the plate with a straight edge. Wipe off all soil adhering to outside the shrinkage dish. Now, we will find the mass of this, which will be your m1. Okay. Once you have done this procedure, you will get the m1 by measuring its mass. Then that dish, what we do now? We put it in the just in a room temperature, so that it gets dried. Okay, because we have a lean soil. So, what we will do? We will put it in the room itself, so that it will slowly dry up. Okay, so that the color of the pad, which was due to its high moisture content, was dark, it will slowly come to become light. Okay, light brown. See, dry the soil of the sinking air until the color of the pad turns from dark to light. Then dry the pad in oven at 105 to 110 degrees centigrade to constant mass. First of all, we will make sure that the top surface of the pad or the shrinkage disc is dried fully. Okay. Only after that, once we have made sure that it is dried, we will now only put it in the oven for full drying. Okay, at nearly 110 degrees centigrade. Now, we will, after we have dried it, we will cool it in the desiccator. Remove the dry pad from the desiccator after cooling. Means now we will remove that soil part only. Okay. Suppose this is your shrinkage dish and this is the soil. Okay. Once it is dried, it will be easily removable. Why? Because if you remember, we had applied here grease or Vaseline. So, it will easily remove. Okay. So, we will take it out. Okay. We will take the whole mass out. Remove the dry pad from the desiccator after cooling and weigh the shrinkage dish with the dry pad to determine the dry mass. Okay, MS. Place the glass cup in a large evaporating dish and fill it with mercury. Remove the excess mercury by pressing the glass plate with sponge firmly over the top of the cup. Wipe off any mercury adhering to the outside of the cup. Remove the glass cup full mercury. Place it in another evaporating dish, taking care of not to spill any mercury from the cup. What does this mean? Actually, if you see in the diagram, you will get it. See this part, we are talking about this part now. What we will do? This is the dry pad which we have now taken out from the shrinkage dish. Okay. this is the glass plate with sponge. Okay. What we will do? We will see this is having this and this and this. You can see in the diagram there are 3 projections of this glass plate. What we will do? This is filled with mercury, okay, totally, and this is a large glass, okay, large dish. Okay. Now we will fill mercury in this fully, okay, up to here. Now this dry pad we will put onto this. You know the density of this is high, so it will not go inside, it will be floating something like this. Okay. This will float like this initially. Now that glass plate with sponge will be used to insert it or force it to go inside. Okay. Force it to go inside. Okay. Hence what we final diagram we will get? We will get something like this. See, this is inserted inside. Why? Because of this sponge. Okay. So now due to this insertion, what will happen? Mercury will flow out. Mercury will obviously flow out, and here it will be gathered here and here. Okay. Finally, what we do? We remove this, collect the mercury and weigh it, and again find the volume. Okay. Like we did in the last time. Okay. Rho is m by v. So v will be finding by m by rho. Okay. So you will get m from measuring this and this. Okay. So rho you already know. So you will get the volume. What does this mean? This volume is actually the volume of this dry pad only. Mass you know, volume you know. So you will get rho. Okay. Is it okay? So from that you can find W. You know gamma B, you know gamma D. So how will you get W? You can also use the relation gamma D is gamma B upon 1 plus W. Okay. This is your shrinkage limit, Ws. Okay. So this is the full procedure to find out. Just see the data sheet. Okay. The whole things are also mentioned here. First of all, you measure the empty dish, then with mercury. Okay. Then subtraction will give you the mass of mercury, then volume of mercury divided by 13.6, then mass of shrinkage dish you can find, mass of shrinkage dish plus wet soil. Okay. Mass of wet soil also you know, because you know the mass of this and this. So wet soil you can find. Again after drying, dish plus dry soil you know, dish you already know, so dry soil also you can find out obviously. Mass of mercury dish plus mercury in the dry pad. Okay. Volume will be also calculated, then mass of the mercury displaced by the dry pad, which you saw in the last diagram. So volume you can find out from there, just I told you by this. Okay. Now these 3 are new terms. Okay. What is, first of all, let us see volumetric shrinkage. It is actually the shrinkage or the volume change, volumetric shrinkage, we can write Vs. Okay. This is the volumetric shrinkage. What is volumetric? V1 minus, generally it is Vd upon Vd into 100. What is Vd? Dry volume, means mass of the soil at dry stage. Okay. Mass of the soil at dry stage is your Vd, and V1 it can be any volume, maybe for W1, W2, any water content corresponding to that V1. Okay. So this is the net volume change from that water content volume, suppose W1 water content volume to dry. Okay. That is your volumetric shrinkage. How much shrinkage will occur from that W to dry state? That is your volumetric shrinkage. What is shrinkage ratio? Shrinkage ratio is V1 minus V2 upon Vd whole upon W1 minus W2 into 100. Okay, into 100. What is shrinkage ratio? It is actually the ratio. You know what is shrinkage is something like this. In this case, remember, we do not have the same parameter here. It is for W1, it is for W2. Volume corresponding to W1 moisture content, volume corresponding to W2 moisture content. Okay. But their ratio is found according to the Vd only, and these are W1 and W2. Okay. For them, moisture contents are these. So this will give you the shrinkage ratio. Okay. Ratio of volume change and water content change. You can say delta V by Vd upon delta W. this gives you shrinkage ratio. Okay, and shrinkage limit already we have found out. So this was it. So some of the questions are here, please refer to them. Okay, that will brush up your concepts. Next time we will be discussing other topics, some important relations corresponding to and some important topics or nomenclatures which we will be using in the geotechnical engineering later on also. We will discuss about them and get your concepts cleared. Okay, so keep watching the videos. Thank you.